What is the difference between the graph of an equation and the graph of an inequality? You need to shade the graph to show the solution to an inequality. First example says to graph the line y equals 3/5 x minus 4. We will use the y-intercept of -4 and the slope of 3/5. This shows the graph of the line y equals 3/5 x minus 4. The second example says to graph the inequality y is greater than or equal to 3/5 x minus 4. Notice that this is the same line. All we've changed is that we need an inequality. So let's start by getting the line in place. Because we have the or equal to with our inequality, we use a solid line. Now we need to choose the correct section of the graph to shade. Because it's greater than or equal to, we would expect to shade above. We can test a point to make sure that we're correct. So let's choose a point above the graph. I'm going to choose the point 0, 0. To test the point, we plug in 0 for x and 0 for y into the original inequality. 0 is greater than or equal to 3/5 times 0 minus 4. That gives us the inequality 0 is greater than or equal to -4, which is true. So this point does work, and we would shade the side that includes that point. The same procedure will apply with a quadratic inequality. The only difference is that our graph, instead of being a line, is going to be a parabola. To graph a quadratic inequality, you're first going to graph the parabola using a dotted line for strictly greater than or strictly less than, and a solid line for less than or equal to or greater than or equal to. Make sure that your vertex is correct, as well as at least one more set of points. To test a point, you want to choose one clearly inside the parabola and clearly outside the parabola to find the region that represents the solution to the inequality. You have to be a little more careful than you do with lines. Sometimes greater than means inside, sometimes it means outside. So you always want to test points. One thing that you can do to help you simplify the arithmetic that you need to do is use the same x-coordinate as your vertex for each of the points that you choose to test. Once you've graphed the parabola, you test your points and shade the appropriate route. Let's do an example. We have an equation that's in vertex form. Since it's in vertex form, we should be able to easily read the vertex. Our vertex would be the point 2, -4. So we can place this on our graph. If you remember, to find your y-intercept, you always need to plug in 0 for x. So to find that y-intercept, I'm going to have, not going to do that, we just need to calculate the value. So I'm going to put my 0 in here and calculate. 0 minus 2 is -2. -2 squared would be 4, and 4 minus 2 is 0. So our y-intercept is the point 0, 0. Using symmetry, we can reflect that across and find that we also have a point at 4, 0. This should be enough to get a parabolic graph. So we're going to draw a nice smooth curve, and this is our parabola. And as I will frequently do, I neglected to pay attention to the fact this is strictly less than. So instead of a solid parabola, I should have done a dotted parabola. So I'm just going to write dotted up here to indicate that I remembered that. All right, now what I need to do is choose a point inside the parabola and a point outside the parabola. For my point inside, I'm going to start at my vertex, and I'm just going to go choose a point above it. So the point 2, 0 looks like it would be nicely inside that parabola. I'm also going to stick with the same x-coordinate and go outside. So I'm going to take the point 2, -7. My next step will be to test each of these points. For my inside point, my y is 0, my x is 2. That gives me 0 squared minus 4, which is -4. 0 is not less than -4. This is incorrect. Let's go test our outside point. My y value is -7. And again, I'm doing the same arithmetic, so I know that this works out to be -4. Since -7 is less than -4, my outside point works, and I'm going to shade my graph to show this. And I'm going to shade all the outside region on my graph. Now let's go on to the next example. If you think you have this, pause the video and try this one on your own. And then once you've got it, start the video again and just make sure that your work is correct. I'm going to start by naming my vertex, which would be the point -1, 5. That's going to fall right here on my graph. My y-intercept is where x is 0, so I'm going to do the arithmetic to calculate that. That 0 squared is 1, or I'm sorry, 1 squared is 1, so I have -1 plus 5, which is 4. So my y-intercept is the point 0, 4. That's right here, reflecting across my my axis of symmetry is going to give me the point -2, 4. If you want to be more solid with your parabola, you can find other points by just plugging in values. I could plug in 1, and if I do that, I'm going to get -4 plus 5, and I'm going to get 1. That's going to give me another point here and a crossover here. I can continue to do this to find more points, or just graph very carefully so that it appears to be a good solid parabola. This is less than or equal to, so I do get to use a solid line this time. And there's my parabola. For test points, I want one inside and one outside. I'm going to use the points, let's just go here inside, so this would be -1, 0. And when I go test that, I'm going to get y is less than or equal to the opposite of -1 plus 1 squared plus 5. That's 0 squared, that's just going to give me 5. This is true, so it looks good, but we're going to check our work by testing a point outside as well. I'm going to test this point right here. So this would be the point -1, 8. And so I get 8 is less than or equal to, and I know since I'm plugging in -1, I'm doing the same arithmetic, so I know it would be 5, and that is not true. So I see that that doesn't work, and I'm going to shade the region inside my parabola. Now let's move on to a new set of parabolas. The next two parabolas are in factored form. So we've added the statement, the request to look for your roots. The roots here would be at the points -2, 0, and 6, 0. That puts them here and here. If you remember, that's what helps us find our vertex. It has to be halfway between -2 and 6. So I can just average those if that helps. That's going to give me 2. So I know my vertex has the x-coordinate of 2, because that's where my axis of symmetry would be running. To figure out the y-coordinate, we're just going to plug that in. So 1/2, 2 plus 2, 2 minus 6. So that's 1/2 times 4 times -4. -16 times 1/2 would be -8. So my vertex is at the point 2, -8. Now we can draw our parabola. And I've done it again. This should be dotted. And to find our y-intercept, I'm going to plug in 0 for my x value. So that's going to give me 1/2, 0 plus 2, 0 minus 6, which is half times 2 times -6. Half of -12 is -6, so I get the y-intercept 0, -6. It should be going through here. I've cleaned up my parabola, so now what we're seeing is the parabola going through the proper points, and it's dotted. Time to choose points inside and outside. I want a point inside, and again, I'm just going to stick something right above my vertex. So I'm going to choose the point 2, 0 for my inside point. And for my outside point, I'm going to take 2, negative 10. So testing inside, I'm going to have 0 is greater than 1/2, 2 plus 2, 2 minus 6. That's 1/2 times 4 times negative 4, which would be negative 8. 0 is greater than negative 8, so this is looking good, but let's test our outside point just to be sure. This time my y value is negative 10, and since I used the same x value, I know that this side's going to be working out to negative 8. Negative 10 is not larger than negative 8, so I will be shading inside my parabola, and my answer is going to look like this. Try the next one on your own, and then check your answers. Check your work. You should have roots at 1, 0 and negative 3, 0. Halfway between there is an x value of negative 1. When you plug that into your equation, you should find your vertex to be negative 1, 8. I fixed my parabola. Now it's facing the correct direction and matching the points that I found. Choose a point inside. I'm going to take the point negative 1, 0. And a point outside, I'm going to take negative 1, 10. And we'll go test those 2 points. Y is less than or equal to negative 2 times x minus 1, x plus 3. So 0 would be less than or equal to 8. And that is true. Let's test it outside. 10 is less than or equal to, we're going to have the same arithmetic because I used the same x value. 10 is not less than 8, so my correct point is the inside point, and that's where I'm going to shade. Now let's move on and do a couple examples in standard form. If you remember to find your vertex in standard form, you need to use minus b over 2a. So minus b over 2a in this case would be minus 2 over 2 times negative 1/3, which would be negative 2 over negative 2/3. When you flip and multiply, that comes out to be 3. So my vertex is at the point 3 something. To figure out the y value that goes with it, plug your 3 in. So we're doing negative 1/3 times 3 squared plus 2 times 3 minus 3. This is going to be a negative 3 plus 6 minus 3, which is 0. So my vertex is at the point 3, 0. Y-intercept is going to be where x is 0. So when I plug that in, when I put in zeros for x, all that's going to be left is my constant. So my y-intercept is the point 0, negative 3. This is my vertex, so my axis of symmetry runs right here. I'm 3 units away, so I'm going to count 3 units on the opposite side. And I have a solid parabola right here. Point inside, let's take the point 3, negative 1. For my outside point, I'm going to take the point 3, 2. When I go test this, I need to work this out, and my y value is negative 1, should be greater than or equal to 1/3 times 3 squared plus 2 times 3 minus 3. This would be 1/3 of 9 is 3, so negative 3 plus 6 minus 3. So negative 1 is greater than or equal to 0. This is not true. So hopefully our outside point will work. My y value now is 2, and that should be greater than or equal to the same value because I'm going to use the same x value, so I get 0. 2 is greater than or equal to 0, so this time I'm going to shade outside my graph. make sure that you're covering all the region outside. And there's our graph. Go try the last one on your own, and then come back and check it. Since we have no b value, our b value would be 0. When I work that out, that gives me a vertex at the point 0, -4. That would also be a y-intercept, so finding my y-intercept isn't going to get me any more points. So what I'm going to do is just choose a point to either side of it to find more points. So if I plug in 1, I can just calculate a new point. So I would be working this out just using 1 for x. So this is going to give me 2 minus 4 or -2. If I have a point at 1, -2, and my axis of symmetry is on my y-axis, that means I also have a point at -1, -2. If you want, you can find more points this way. And this time we have a dotted parabola, and it's going to come right down here. And we'll choose a point inside. I'm going to work with 0, 0. And a point outside, I'm going to take 0, -6. My inside point, when I go to test that, I'm going to get y is greater than 2 times 0 squared minus 4. This is all going to be 0 minus 4, so 0 is greater than -4. This is true. It's going to test our outside point, -6, greater than, we use the same x value, so that's also going to be -4, and this is not true. So we will be shading inside our graph. And there it is. You have 6 problems for homework that are very similar to these. You should be finding all the points you need. List those on the worksheet along with it, and graph and shade.